Okay, this lesson is on simple machines. Now, before we get into talking what simple machines are, we do need to go over a few terms. So one of those terms you need to know is work. So you've heard, going to work, doing work. You hear all of this, but what is work? So the definition here says the transfer of energy to an object by using a force that causes the object to move in the direction of the force. And you even have a formula to calculate work. So work is equal to the force times the distance. So you know how I like to break things down. So pretty much what work is using a force to move an object over a distance. So using force to make something move. Now we can measure, using our formula, work is equal to force times the distance. Work is measured in joules, and this is a unit to measure energy. So here's an example. If we wanted to calculate work, so it is force times distance. So let's say we push an object 80 newtons, and the object is pushed with a force of 80 newtons over 1 meter. You will get 80 Newton meters, which is actually equal to a joule. So that would be 80 joules would be the work. Okay, power is another term. This is the rate at which work is done or energy is transformed. So how fast is work being done? And it's kind of almost like speed. Speed is a rate, and so is power. So power is work divided by time. This is measured in watts. And you've heard watts before when you think of like electricity. So watts is the unit to express power. Okay, so now let's get into the machines. A machine is something that's just going to make work easier by changing the size or the direction of the force. So you're not having to push as harder, you're not having to work as harder. It makes work easier. It makes life easier. So there's all kinds of machines. Almost everything around you is a machine. But let's talk about the simple machines. What do we start with? So the first simple machine is an inclined plane. This is a ramp or slanting surface that connects a lower level to a higher level. So if you notice here, it's like a ramp, like a skateboard ramp as an example. An escalator, stairs, all of these are examples of inclined planes. Now what inclined planes do is they make it easier to lift something that is heavy. You end up using less force by pushing it up a ramp instead of straight up. So think about if you didn't have an escalator. How hard would it be to get to the first floor to the second floor? You have an inclined plane, which will make it easier. You may have to go more distance, but you'll use less work. Okay, the second one we're going to talk about is a lever. This is a stiff bar that rests on a support called a fulcrum. And the seesaw is the best example to talk about a lever, but there's first class, second class, and third class, and we'll get into that. But the spot that the bar rests on is the fulcrum. So a shovel is an example of a lever and a seesaw. So what the lever does is it reduces force needed to move an object like other simple machines. It's going to reduce the force. Third one we're going to talk about is a pulley. And the first thing I think about when I think of a pulley is opening like blinds. If you pull that string down, it actually works. You are lifting the blinds using a pulley. So a pulley has a grooved wheel with a rope or cable around it. And here's a good example here. Here's the grooved wheel, and here is the rope. So what the pulley does is it changes the direction of a force, which can make it easier for it to move. So you're changing the direction of the force with the pulley. All right, the fourth one we're going to talk about is a screw. This is an inclined plane wrapped around a pole. And if you remember talking about an inclined plane, it goes from a lower point to a higher point. And if you actually were to follow the screw all the way up, you will see that it's going to go from a lower level to a higher level. So what screws help us do is they help keep things together. It helps to keep things together. So it's a lot more useful to keep things together than, let's say, a nail, which we're going to talk about next. So the fifth thing we're going to talk about is a wedge. And I was saying a nail, this is an example of a wedge. A wedge has a slanting side ending in a sharp point, and it is used to split, lift, or it can even hold. So it does help push things apart. So you think about, you see the axe in the picture. A knife is considered a wedge. Some shovels, the bottom of the shovels, and things of that sort. The last one we're going to talk about is a wheel and axle. So wheel and axle is a circular device with a rod that is called its axle through its center. So what a wheel and axle does, and you've seen this, it helps move heavy loads for longer distances, and you're using less force. And the axle helps to support the load. So you see the car, you see bicycles, trains, anything with wheels have wheels and axles to help move a heavy load over distances. But even things such as clocks work by wheel and axles. Now, a lot of things in the world are made up of several different types of simple machines. And when you have two or more simple machines that work together to do work, that is called a complex machine. You may also see this as a compound machine.